guys, welcome to DESI ASTRO. So in this Python tutorial you are going to learn that how to do multiple linear regression in a single plot. So basically we are going to fit line between the scatter plot using np.ployfit. So you can see here that we have a sample image, and here you can see that we have a three scatter plot and the three lines, and we have obtained its intercept and the slope for the best fit using np.ployfit. So same stuff we have to do it using np.ployfit. So let's do it. Okay, so first we'll import library. So we'll import numpy as np. So this will take care of your array, and you will also import matplotlib .pyplot as plt. So this is used for plotting. Now you can define your x and y data. So here define your x and y data. So as multiple. Okay, so we'll have like multiple x and multiple y's. So you can define your say x1 equal to, you can define say np dot linear space and you can give a range from 1 to, you can give 1 to 100, and you can give say 20 data points. Okay, so similarly you can define your y1 equal to, and you can give as a x1 and you will add some noise. Okay, so here you can y1 equal to x1 plus noise. So for adding noise you can import your library, import random. Okay, so this will add noise in a scatter plot. So you'll get it what to do in a minute. Now suppose you want to plot without noise. So if you add here y equal to x1 plus np dot random dot rand int, so it will like give random integers and the size should be same as your array size, should be 20. Okay, so you can give say you want to give 10 to 60 and then 20 random points. So this become your x1 and y1. You can plot it simply plt dot scatter x comma y, and you can type plt dot. So you can also give some size is equal to 200, run it. But there should be x1 and y1, not xy. Okay, now run it. So here you got a simple plot. So without your noise, your plot will look like that, simply a straight line. So for fitting line through it, I am adding noise. So the plot will be now appear like this fashion. Now so same way we need to define your x2 and y2. So define x2 and y2. So quickly we'll do, you can give say x2 equal to just copy paste it, and I'll just change the numbers. So in there 10 to 10 to, or you can give say 200 to 200, then 20 numbers, and then you can give y2 equal to, just copy paste it and put it here, x2, and then you can add here some random numbers, and similarly you can define here x3 y3. You can add as much as you want, x3 x4 x5 also, but I will do only for uh, three sets of linear regression now. So you can give x3 equal to, just copy paste it, and I will go from 3 to 100, and then I will get y3 equal to x3 plus noise. I will add, and random I will go from 10 to 80. Now I have this much plot. Now I want to plot it. Okay, so I will just plot it. So you can plot in a simple way. So I will type here plt dot scatter, and I will go here x1, x2 and x3, and then comma I will go for y1, y2 and y3. So all plots will be plotted together. Now run it. Okay, so here you can see that you have three plots together, but I think we can much more visualize from here. Okay, so you got the three plots. Now we have to fit a line through it. Okay, so for that, now fit line through it and obtain slope and intercept. So basically I will do putting like y equal to mx plus c. Okay, so let's do it. Okay, so for that we need to you need to use for loop. Okay, so here you use for loop. Okay, so use for loop for multiple line fitting. Now type here for y in, and then you can pass your y, y1, y2 and y3. So similarly you go for x, so for x in x1, x2 and x3. Okay, now we will type here say p of p is your optimized parameter, and p covariance is your it's like your covariance matrix, and it contains like your 2x2 matrix, and its diagonals give you the error in that. So basically I will take its diagonal and then take its square root, so it will give the error. Okay, then type here np dot np.ployfit and then pass your x and y. Okay, x and y and order. So order should be 1. 1 means line. Okay, so here I can give comment. So here POPT is optimize parameter. So basically it contains your slope and intercept, and P covariance is your 2 cross 2 matrix. Okay, and it will let find error. So it gives error. Now you can also make it covariance equal to true to operand covariance. Now this much we have done. Run it. So we have run it successfully. Now you can print it if you want, or maybe basically you can also plot. Okay, so basically your line model becomes your fit line becomes POPT 0. Basically it becomes your slope into x plus POPT 1. Okay, so here POPT 0 equal to slope and POPT 1 gives your intercept for that line. Now it's time to show the fitted line. So for that, come out from the loop and type here plt.plot. You can pass your x and then you can pass your say fit line. Okay, now run it. Okay, so here you can see that 3 lines and they are fitted with corresponding colors. Okay, now maybe you can visualize with much let's run it once again. Okay, so here are 3 lines. You can make line width more. Line width equal to, you can make it 10, make it 5. Okay, now you can also give label if you want. Okay, so better you can plot this all. Yeah, so you can give label here. Label equal to scatter 1. Marker. Okay, So here you got three things, like one is your like green dot, one is your like triangle, and other is your star. So for three data points we have like three plots. Now you can also give a label to this fit. So type here label and then pass it as a tuple. So you want to give also your slope m equal to percentage f, and also your intercept equal to percentage f, and then you can put it as a tuple. Okay, so percentage tuple, and then give it as a your POPT. Now run it, or just put here plt dot legend for plotting. Now here you can see that the three types of scatter plot and their slope and intercept is given. So this way you can plot it. Okay, so this is the code for multiple linear regression using np.ployfit. So we have libraries. We have imported the 3x and 3y's, and we have plotted a scatter plot. Then we have used for loop for x and y. We have obtained optimized parameter POPT and covariance matrix, and we have fitted line, and then we have obtained slope and intercept for the line. So this is the slope, this is intercept for individual lines. Okay, and so if you want error, so error in slope and intercept. Okay, so if we type here or maybe you can go above and here. So if okay, so just type here print error in slope and intercept. Okay, so just pass here, you can do here error equal to np dot square root of np dot diagonal POPT, or sorry, P covariance. Okay, and then pass here your error, so it will print error in that. Okay, so you can see here that maybe you need to print outside. Okay, so here you can see that this is your error in slope and intercept corresponding. Okay, and here is your slope and error for respective fit. So this way you can do. So I hope you got the idea that how to fit a multiple linear regression using np.ployfit. So thank you.